Okay, I don't know where we're going to get to in class, so I'm just going to start here and hope for the best. So this one says, a ladder 25 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. How fast is the top of the ladder moving down the wall when the base of the ladder is 7 feet from the wall? So notice this is more like what you're going to see on a test, on the AP test, on my test. It's not going to have those boxes for you. Those boxes were just to kind of get the feel of it. So we have a house. We're going to say it's a tall house. And we have a ladder leaning against the side of the house. Right? So the ladder is 25 feet long. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. So I'm going to call this B for the base. Or maybe we could call it X. I don't know. Do you want X or B? We could do X because it's horizontal, right? And then this, if it falls down, we could call that Y. So think about what we know, okay? These two are going to change as it moves. That's why they are variables. But is the length of the ladder ever going to change? No, it's always 25 feet. And so that's your constant, and these are your variables, right? So dx over dt would represent the rate that this is moving. And so it's pulled away at a rate of 2 feet per second. So if this ladder is pulled away, is that going to be getting bigger or is that going to be getting smaller? That should be positive, right? It's getting bigger, so that would be 2 feet per second. And then we want to find dy over dt. That's our missing rate, right? So what equation could we write relating these sides? Well, that would be Pythagorean theorem, right? We could say x squared plus y squared equals 25 squared. And I can leave the 25 in there because it's a constant. So this would be 2x dx over dt plus 2y dy over dt. And the derivative of 25 is 0. And I'm looking for how fast is the top of the ladder moving down the wall. So I'm looking for this. When the base of the ladder is 7 feet from the wall. So when x is 7, what else would I still be missing here? I'm missing y. And so this is that extra equation that we have to do sometimes. So if we know x is 7, could we say 7 squared plus y squared equals 25 squared? Move that over, you get 576 if you subtract 25 squared minus 7 squared, and you take the square root and you get y equals 24. My computer made a weird sound, which makes me think the volume's going to be messed up, but let's hope for the best. So that's my extra value I needed, so now I'm just going to plug stuff in. X is 7, when dx over dt is 2, y is 24, and I'm looking for dy over dt. So 7 times 4 is 28. So the 2 times 24 would be 48 dy over dt. And if I subtract that over, that would be negative 28. And then I divide by 48, and I get dy over dt equals negative 7 over 12. And the rate would be feet per second. So think about for a minute if that makes sense. If this is going down, then that height is going to be getting smaller, and so that makes sense that our derivative, our rate, is negative. Okay, so look at part B. It says, consider the triangle formed by the side of the house, the ladder, and the ground. Find the rate at which the area of the triangle is changing when the base of the ladder is 7 feet from the wall. So the area of that triangle would be what? Area of a triangle is 1/2 base times height. Well, in this case, our base was x and our height was y. So on this one, we want to find the rate at which the area is changing. So we're trying to find dA over dt. How would I take the derivative of this? I would need the product rule, right? So that would be dx over dt times y plus 1/2 x times dy over dt. Really nice. They keep it at the same time when the base of the ladder is 7. So that's our same x is 7. We already know dx over dt was 2 feet per second. And at 7, we found up here that it was negative 7 over 12. So we can use those same values to solve this. So dx over dt was still 2. Y is still 24. X is 7. And dx over dt was negative 7 over 12. So when you do this in your calculator, oh, it just made the noise again. Sorry, I'm typing this in my calculator. So that's just 24 plus 7/2 times negative 7/12. And I get 21.958. If we're talking about units here, area is going to be in square feet per second. So at this moment, the area is actually getting bigger, because think about if this was going down and this was going out, it's actually getting bigger. Interesting. What about this one? Find the rate at which the angle formed by the ladder and the wall of the house is changing when the base of the ladder is 9 feet from the wall. So think about again for a minute. This is x, this is y, but now this is theta. This is 25, and if they tell me x is 9, that's going to come into play later. But first of all, what could I write with theta here? There's a lot of ways you could do this, but could you set up cosine of theta equals x over 25? Or you could do sine of theta is y over 25. Why did I do x? Because they gave me the x value. That's why I did cosine. So the derivative of cosine would be negative sine of theta times d theta over dt, and that would equal 1/25 times dx over dt. The nice part also of using dx over dt is they gave me the rate that x is changing. Like they gave me that up top that it was 2. So if I just fill in what I know right away, I know this is 1/25 times 2. Do I know what sine of theta is? Well, I could figure it out, right? Because sine of theta is going to be y over 25. So if x is 9, could I do 25 squared equals 9 squared plus y squared? And so I think that you get y squared equals 544. So you would get y equals the square root of 544. And I mean, I guess you could simplify it, but I'm not even going to. That would be sine. Like sine is opposite over hypotenuse. So that would be negative square root of 544 over 25 times d theta over dt equals 2/25. So if I want to solve that, I'm just going to multiply by the reciprocal, right? So I would multiply by negative 25 over the square root of 544, because those would cancel out. And I could get that d theta over dt would be negative 2 over the square root of 544. And what units would that be? That would be in radians per second. Okay, that was a lot. And I don't even know if my volume's working. All right, I want to try to do this last one. It says, oh, it's actually a lot of them. It says, an airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. When the plane is 10 miles past the antenna, the rate at which the distance between the antenna and the plane is changing 240 miles per hour. What is the speed of the plane? So, I feel again that this is going to be a triangle. Gosh, I'm struggling. So, if I have my airplane here, I'm not going to attempt to draw it. And it passes at an altitude of 5 miles, so that would be this length, right? When the plane is 10 miles from the antenna, so that would be this way, right? The rate at which the distance between the antenna and the plane is changing. So like if the antenna is down here, right, we'll kind of be looking at this triangle that we could make. So let's think about which ones are constants and which ones are changing. Well, this is definitely changing, right? The distance between the antenna and the plane, because the plane's like going this way. So this is definitely a variable. I don't know what you want to call it. I'm going to just call it y. What about this? The altitude. Is the altitude going to change? No. So that's going to be a constant. But this one, when it's 10 miles, they give us the rate. And so even though this is 10 miles, this is also a variable. So that's going to be x. So that's important. What's a variable? What's a constant? And then write your equation. So x squared plus 5 squared equals y squared is going to be the equation I take the derivative of. But if I know this is 5 and this is 10, I can also find what y is, right? And so like my side equation is I could also say 5 squared, or if I go in order, 10 squared plus 5 squared equals y squared. So 125 equals y squared. And you could break that up, but I'm just going to leave it as that for now. So that's like my side work. Take the derivative of this would be 2x dx over dt. Derivative of 5 squared is just 0, and I get 2y dy over dt. So I know what x is. I know what y is. I know the rate at which the distance between the antenna and the plane is changing. What does that represent? Is that dy over dt or dx over dt? The distance between the antenna and the plane. So this would be dy over dt would be this. The speed of the plane, think about the rate that the plane is moving. The speed is dx over dt. What do you think about that? So if I plug all that in, I get the square root of 125, and I'm solving for dy over dt. No, wait. I'm solving for dx over dt, and that's 240. And you could use a calculator. These are usually calculator questions, but you could just divide, right? Divide by 2 times 10. These 2's cancel. I could even cancel this out, and I would get that dx over dt is 24 times the square root of 125. And I could type that in the calculator as well. And that would be in miles per hour, which makes sense for speed, right? That the derivative, the rate that the plane is moving, is the speed of the plane. Okay. 14 minutes. Okay. So there's 2 more here. I would like you to see where you can get on these, and then we'll go from there in class. Also, this is an exercise.